On December 27, 2004, something hit Earth. Not an asteroid, not a comet. A wave of energy from a star so violent, so incomprehensibly powerful that it traveled 50,000 light years across the galaxy and still hit our atmosphere hard enough to partially ionize it. 50,000 light years away. And it still reached us. If it had been even slightly closer, we wouldn't be here. So, what actually fired at us? Something called a magnetar. And to understand why magnetars are so terrifying, you first need to understand what they are actually made of. When a massive star dies, and I mean a star much bigger than our sun, the outer layers explode in a supernova. But the core, something that was originally larger than our sun, gets compressed down to a ball roughly 20 kilometers across. 20 kilometers. You could drive across it in 15 minutes. But that 20-kilometer ball contains more mass than our sun. 1 teaspoon of this material, 1 teaspoon, weighs about 1 billion tons. More than every building ever constructed by humans combined in a teaspoon. This is called a neutron star. And on its own, it's already one of the most extreme objects in the universe. But a magnetar takes it further. A magnetar is a neutron star with a magnetic field so powerful it has no comparison to anything else we know of. Our Earth has a magnetic field. It's what makes compasses work. It's what shields us from solar radiation. It feels invincible and gentle. A magnetar's magnetic field is a quadrillion times stronger than Earth's. If a magnetar was slightly halfway between here and the moon, which is 190,000 kilometers away, its magnetic field would be strong enough to pull the iron out of your blood from that distance. Not attract you, pull the iron atoms out of your body. And the field is so intense that it does something that sounds like science fiction. It actually distorts the shape of atoms themselves. Atoms near a magnetar aren't round anymore. They get stretched into thin cylinders by the magnetic force. Matter, as we know, it stops behaving like a matter. And here's the thing about magnetars that keeps scientists up at night. They are unstable. The surface of a neutron star, called the crust, is under unimaginable stress. The magnetic field is constantly pulling and twisting it, and sometimes, like a fault line in an earthquake, it snaps. We call it a starquake. And when a magnetar stress cracks, even just by a centimeter, the energy released is catastrophic. On December 27, 2004, a magnetar called SGR 1806-20 had a starquake. In 0.2 seconds, less time than it takes to blink, it released more energy than our sun will produce in the next 250,000 years. All of it in 1/5 of a second. That piles of gamma rays and X-rays crossed 50,000 light years of space. Remember, even at the speed of light, that should take 50,000 years. And by the time it reached Earth, it was still powerful enough to ionize the upper atmosphere. It confused satellites. It triggered radiation detectors worldwide. Astronomers who were tracking it described it as, by an enormous margin, the most energetic event ever recorded from outside our solar system. And we had no warning. I want to ask you something. If that magnetar had been 10 times closer, still thousands of light years away, the pulse would have stripped away the ozone layer entirely. No atmosphere, no protection from solar radiation. Does that change how safe you feel about Earth's position in the galaxy? Drop it in the comments. Scientists have calculated that a magnetar starquake within about 10 light years of Earth would be extinction level. The good news? There are no magnetars that close. The nearest known one is thousands of light years away. The uncomfortable news: we don't know how many magnetars exist. They are incredibly hard to detect unless they are actively flaring. There could be dead, silent magnetars much closer that we simply haven't found it. And magnetars don't stay active forever. They typically burn out over roughly 10,000 years as their magnetic field slowly weakens. After that, they become a regular neutron star, quiet and undetectable, which means the ones we found are the only ones currently screaming loud enough to notice. We've only confirmed around 30 magnetars in the entire Milky Way. one in a galaxy of 400 billion stars. They form from a very specific type of stellar collapse. Not every massive star produces one. The exact conditions that create that insane magnetic field rather than a regular neutron star aren't fully understood yet. Something in the rotation speed, something in the original star's composition, the details are still being worked out. What we do know is that their early life, the first 10,000 years, they are genuinely the most dangerous single objects in the galaxy. More dangerous than black holes in one specific way. Black holes pull things in. You have to get close. A magnetar can reach out across thousands of light years and still affect you. And this story has a recent chapter. In 2020, for the first time ever, astronomers detected a magnetar producing something called a fast radio burst, an incredibly powerful millisecond pulse of radio waves that we'd been detecting from distant galaxies for years without knowing what caused them. Suddenly, that mystery had an answer, and it changed everything about how we think about those signals. Fast radio bursts. These flashes we'd been seeing from billions of light years away could be magnetar starquakes, which means what we've been actually detecting from across the observable universe is the equivalent of what nearly affected Earth in 2004. Happening constantly in every direction. Here's what magnetars actually tell us. The universe is not a calm, empty space waiting to be explored. It is violently, actively, continuously exploding. And the only reason life exists here is because of an almost improbable series of distances and timing that kept us just far enough from the worst of it. 50,000 light years away still reached us. That's not a threat, that's just Tuesday in this galaxy. The fact that you're here watching this, that's the remarkable part. Not that dangerous things exist out there, but that somehow, so far, we've been lucky enough to be just out of reach. Subscribe because the next one is going to make this look calm.